Yeah, I think I can borrow 5 minutes from the previous presentation. Nice. So yeah, today we're going to talk about a Bitcoin L2 called Rootstock and its smart contract capabilities. Okay, sorry. My name is Raul Laprida. I'm head of architecture at IOV Labs. Before that, I worked as a researcher as well as IOV for almost 4 years. Today, we'll cover a technical overview of the Rootstock blockchain. And also, I want to show you how easy it is to port existing Dapps to Rootstock for an Ethereum ecosystem. And I'll give you a list of resources, which I hope you can get the slides so you can have them. Otherwise, I have some QRs for you at the end. Let's start with the overview. So if we had to summarize Rootstock in a couple of sentences, okay, it's not, the slides are a bit messed up, sorry about that. So it's its own blockchain, but it's a sidechain of Bitcoin. It is secure, mined by the Bitcoin miners, and it is fully EVM compatible. So whatever you have on Ethereum running right now, you can port it directly to Rootstock, and it will work. That means that you can have all that existing ecosystem, but with the advantage that Rootstock has Bitcoin as the native cryptocurrency, so all your protocols can use natively Bitcoin or any asset that is backed by Bitcoin natively. And I'll explain a bit later how that works. Our main component is the node, the reference node. It's called RSKJ. It's a short for Rootstock Java. It was originally forked from Ethereum J a long time ago. This is a blockchain that started running on mainnet on January 2018. And it's open source. You can collaborate through pull requests. There you will find the white paper, which is the technical explanation, and the one that we use for the reference implementation. Any proposal, any improvement is done through Rootstock improvement proposals, similar to what you have on Ethereum with EIPs or Bitcoin with BIPs. You have the repo there. Basically, it's a collection of markdown files that you can submit if you want to propose something new. And all the active discussions happen on the Rootstock Research Forum, as well as on the GitHub repo. And the last link is a nice repo where you can see all the RSK IPs divided by categories. So what's the relationship between Rootstock and Bitcoin? Well, Rootstock is a sidechain of Bitcoin. That's very important. And it's intrinsically connected to Bitcoin in both Bitcoin as a network and BTC, which I will call BTC. Sorry, it's also messed up. Sorry about that. The arrow should be in between the BTC and RBTC. And also connected with the BTC coin Bitcoin. So in regards of the connection with the network, we are a sidechain. Our blocks, the Rootstock blocks, are mined by the Bitcoin miners. So how does this work? It's a technique called merge mining. Basically, let me explain first how the mining works. So you know most of the hashing power is comprising the mining pools. So we have this client-server architecture where the mining pools send templates to the miners, which are the clients, so they can solve this cryptographic puzzle, which has a certain difficulty. That you can see it as the number of zeros that a number has to have on the left side. And what Rootstock does is it piggybacks on that Bitcoin block, and a reference to the Rootstock block is added in a specific part of the Bitcoin block. To be more specific, it's a field of the Coinbase transaction. It's a 32-byte piece of data, so it doesn't require any change on the Bitcoin node. And what the client does, the miner does, is it solves the proof of work on top of that Bitcoin block. And the difficulty of the Rootstock block is slightly less, it's slightly lower than the one of Bitcoin. So what we can do is reuse the work that they do, the shares that they solve, which are blocks that they solve that only serve for accountability purposes in the mining pool. And if that solution has a difficulty that is enough for securing the Rootstock block, they will relay that to the RSKJ node, because it's enough for us to secure the block. Of course, if there is a block that solves both Bitcoin and Rootstock as well, they are going to share that with the Rootstock node. And that's the way that it works. It's very simple. We also have a security measure called Armadillo, which aims to prevent, detect, disincentivize forks from malicious miners. Basically, well, you have the link that Berek explains it, but basically what we do is in those 32 bytes, on top of the reference to the rootstock block, we add a certain fields. We are not extending the 32 bytes, and that helps us detect these fork attempts. And our relationship with the Bitcoin currency, well, it's pretty evident. We don't have a native cryptocurrency other than Bitcoin. So we actually use Bitcoin on Rootstock to pay the gas and having it as the only native cryptocurrency. The way it works is through a two-way peg. It is called the POW peg, and it's comprised of precompiled smart contract on the on the Rootstock side, multi-sig on the Bitcoin side, and then we have the federation of which we call the pegnatories, and their only responsibility is running the node, which has a hardware security module, which is tamper-proof. It can be publicly attested, the firmware, and it has deterministic builds. This hardware security module is the one that has the cryptographic material to sign the Bitcoin transactions, which are the ones that unlock the Bitcoins on the Bitcoin side. And we call it the POPEC because when the bridge contract that instructs the HSM devices to sign a payout transaction, they actually need to wait for a specific amount of proof of work to be built on top of that transaction before actually signing it. So basically, these pegnatories, they cannot steal funds. They cannot instruct the HSM to sign whatever they want. They cannot actually censor any input UTXO because that's the job of the bridge to select which UTXO is going to be used for the payout transaction. So basically, the responsibility is to power on the device and keep it connected to the internet. But what happens if there is a catastrophe and most of these devices go offline? So the two-way peg would stop working. For that, we have an emergency multi-signature, which is time-locked. So in the event that the community understands that the two-way peg stopped working, after some time, this emergency multi-signature is going to be activated, and it will be used to recover and create a new POPEC with those funds. So yeah, that's the relationship in a nutshell. And what's the relationship with Ethereum? Well, Rootstock has smart contract capabilities. We have a virtual machine, which is Ethereum compatible at the opcode level. So basically, we have all the same opcodes. If you take a Solidity smart contract, or even if you take a compiled Solidity smart contract, I mean the bytecode, you can grab it and port it to Rootstock, and it will work out of the box. We have the same inputs, the same outputs, and the same outcome of the opcodes. The implementation might be different because we have our own reference implementation, but they do the same. This means that all the tooling, compilers that you have for Ethereum, they work out of the box on Rootstock. There are some configuration differences that I'm going to explain later, but everything works on Rootstock if it works on Ethereum. And we are also compatible at the interface level. You know, the apps need to interact with the nodes, and they do that through this JSON RPC interface. We are compliant, we are equivalent as well with the JSON RPC reference of Ethereum. So the only thing that you need to do with the app is changing the URL that you're connecting to, and it will work, taking into consideration the configuration differences that I'm going to explain later. So we covered part of what Rootstock is. Well, we know what Bitcoin is. IOV Labs, I introduced myself as head of architecture at IOV Labs. We initially developed the Rootstock blockchain, and now we support it alongside the community. And we are also developing this RIF framework, which I'm going to start explaining now. It stands for Rootstock Infrastructure Framework. It's both a framework, it's also a token. It is a suite of applications and services that use the Rootstock blockchain as the backbone, and it's basically a complement for any developer who wants to build on top of Rootstock. And it solves a lot of scenarios for the developer community. This is one of the visions of IOV Labs, which is everyday DeFi. Basically, it's enabling everyone to be able to execute a certain set of financial primitives, which are explained there. Is saving with low-risk stablecoins, being able to borrow without putting collateral, sending remittances, money overseas, with cash on and off ramps available, and being able to receive your salary in crypto and pay your utility bills using crypto. And on the right, you have the stack of Reef services. Reef services that enable this. On top, you have the USD Reef, which it's our Reef-backed stablecoin. It's an ERC20 token. And then you have, for example, I'm going to highlight a couple of these. Reef aggregation is our CK rollup solution. It is heavily based on CK Sync. As you know, CK Sync runs on Ethereum. And since we are Ethereum compatible, it was very easy to port it to Rootstock. Reef Relay, it's our meta transaction and account abstraction solution. It is very optimized, so the gas footprint is very low. The actual proxy is written in Bitcoin instead of Solidity. And it enables any user to pay for the transactions using any ERC20 token. And then we have, well, the cross-chain token bridge. So you can cross tokens between bridges, ERC20 tokens. And the flyover is a service that allows you to do fast peg-ins and peg-outs without having to use the two-way peg. So you don't need to wait for all the confirmations, especially for the peg-outs, in exchange for a fee, of course. So I want to wrap up this introduction to Rootstock with a couple of numbers. So I mentioned that we are mined by the Bitcoin miners, and right now we have about 50% of the Bitcoin miners mining Rootstock. Our block time is much less than the one from Bitcoin. It's 30 seconds per block, and it's higher than the one currently on Ethereum, which is 12 seconds. Our throughput at the moment is 10 transactions per second, so it's similar to what you have on Ethereum. But we are working right now, we are at the testing phase of the parallel transaction processing, which is going to increase this number. More importantly, the gas cost of running something on Rootstock is about 2% of what it would cost on Ethereum. So I mentioned that we are EVM compatible. So imagine that you have the same service on both blockchains. Doing the same thing on Rootstock would cost you 2% of what it would cost you on Ethereum. And that's not considering when Ethereum is with network congestion. During that time, it would cost you less than 1% of what it would cost you on Ethereum. I'm going to highlight just one of these because I think I mentioned most of this. So right now, the total token market cap, that is the circulating tokens on Rootstock, including RBTC, which is the Bitcoin on Rootstock, is about $240 million USD. And the current amount of Bitcoin locked on the two-way peg is about 3,500. But there's no limit on how much Bitcoin you can have locked there at the moment. And now for the examples on how to actually develop using Rootstock. So I mentioned that we are VM opcode compatible and also JSON RPC compatible. So if you are an Ethereum developer, it's very easy to develop on Rootstock. Basically, you can use the same tools, the same contracts, and the same libraries. So if you are a developer, an Ethereum developer, you are already a Rootstock developer. We also use the same standards since we are EVM compatible. So you will find solutions and protocols running on Rootstock using the same standards. And you also find a lot of projects using the same implementation contracts. For example, the ones provided by OpenZeppelin, they all work on Rootstock. And now I'm going to talk about those configuration differences that you need to take into consideration. Basically, these are two. You know, when you create your account, you have this seed phrase, 12 to 24 words, that you need to have as backup, and you can always get the same accounts from that seed phrase. Is deterministic. The algorithm uses a path that is defined on BIP 44, that is Bitcoin Improvement Proposal 44, and it has a sequence of numbers separated by slashes, and one of those values is the coin type. And the coin type is the native cryptocurrency of the blockchain. For Ethereum, that number is 60. So if you're using a wallet or a tool that is created to work on Ethereum, it is likely that it will have hard-coded 60 there if you are using mainnet. So if the tool that you're using is not supporting natively Rootstock, you will have to change that number to 137, which is the number for RBTC on mainnet. And those numbers are in the SLIP 44, which stands for Satoshi Labs Improvement Proposal 44, which is a directory of all the coin types for any blockchain. So for Ethereum, you would find 60 for mainnet. For Rootstock, you would find 137 for mainnet. So that's one of the changes. So you need to take into account that. Otherwise, you're not going to get the accounts for Rootstock from your seed phrase. And the other difference is the checksumming. So you know when you type your address, you can input typos, and you would send the money elsewhere because you introduced that typo. So on Ethereum, they use EIP 55, which is the checksumming algorithm basic. It takes as an input your address, and it has some letters uppercase, and it can verify that you didn't introduce a typo. It cannot fix it, but it can verify that you introduced a typo. So since it only uses the address as input, it's not multi-chain. So what we did is implemented a checksumming algorithm using EIP 1191, which adds as a prefix for this algorithm input the chain ID. The chain ID is defined. The chain IDs are defined on EIP 155. Basically, what we do is, since we add the chain ID to the input of the algorithm, we can have a checksumming algorithm that is chain aware, and that's the one that we use. So if the tooling that you're using is not implementing EIP 1191, you will have to disable the checksumming check. How do you do that? By entering the address lowercase. So in that case, you will have to have your implementation of EIP 1191 before sending the address to this tool, so you can do the checksumming, or you can skip the checksumming altogether. Wallets already is implementing EIP 1191, Trezor, Ledger Live, they already include this EIP. They have it implemented. So they are chain aware. So basically, that's it. If you are an Ethereum developer, you're already a Rootstock developer, you can start porting or creating your solutions using Solidity or any other language that compiles to EVM opcode right away. And now for some examples. I'm with time. Oh, I'm very good with time. So this is an example using Web3.js and WebSockets. It is very simple. So if you are an Ethereum developer, you wouldn't notice anything different. It's just creating a provider and subscribing to an event. So the only difference here is that it's pointed to a testnet node on Rootstock instead of a testnet node on Ethereum. And that's it. It's very simple. Now I wanted to show you one of these services from the Rift stack. And this one it doesn't interface with the chain, so it doesn't use the Rift token. It's just a tool that you can use to connect your wallet to your DApp. Since I don't have my laptop here, this is a QR that you can go and check the sandbox yourself. But I recorded a video. I don't know if you can see it. Hopefully you can. This is a very simple React app. It has 2 buttons, and it's just going to log in to your wallet by using the rlogin service. It's just calling the connect method, and it's going to do a lot of stuff. OK, it works. Here I'm logging. It's going to present you a pop-up with a lot of options to connect to your wallet. It could also have Wallet Connect. Nifty, for example, this version doesn't have it. Here I'm going to select MetaMask. I'm just going to connect to a wallet. And that's it. And this is one of the services that you can use freely with Riff. Now for some resources. I have a QR later if you don't get these slides. So these are divided by category. On the left, you have the technical resources, the land page of Rootstock, the most important one, which is the dashboard. Sorry, the dev portal, technical information. You are going to find all the links, all information about Rootstock. On that link, you have the RSK IPs and also the dashboard of RSK mainnet with a lot of interesting stats. And of course, the links for the white papers, both Riff and RSK. On the upper right, you have the developer resources, basically the faucet if you want to test RBTC or test Riff. We have two sets of explorers, the legacy ones, which are the ones that we implemented and we still support. And also we have now a Block Scout flavor for the same explorer. You have the list of public nodes if you don't want to instantiate one for your testing. And also the APIs for Block Scout and Covalent. And the last link is just a link for all the solutions that we have available on Rootstock. GetBlock is just one example. It's a node as a service solution. And on the lower right is all the more research-oriented links, explanation of sidechains, the flyover protocol, how the two-way peg works. And the last link is how we ported CK-Sync to Rootstock, basically. And you will notice that it was very simple. And here are some QRs if you want to scan them. The one on the right is the dev portal that I mentioned before. And on the left, you have our Discord channel. If you want to discuss with the community or with us about technical stuff or non-technical stuff about Rootstock or Riff, you can do it there. We also have two sets of courses. They are very simple, but if you want to use them, it's a user course and a developer course, which is available on that link. And yes, this year we are running a grant program. It's a total of 100 grants. It's divided into 4 waves, a total of 2.5 million USD in prizes. Those were the teams of Wave 2. We are starting Wave 3 soon. And the topics for Wave 3 are generating sustainable yield using RBTC, which is Bitcoin and Rootstock, and real-world assets, or any type of asset, really. Bridging Rootstock with other L1s and L2s. That's the second topic. And the third topic is using user-centric utility, which is repeated. It basically is a very broad topic because anything that brings utility to the user would apply to that subject. You don't need to have your solution ready. You just need to have your idea. You submit it, and then you need to pitch it. And if you win, you get the grant. It's very simple. And that's the link for subscribing to the grants. And that's it. So yes, I have time for questions if you have some.